Hello everyone. So today we will solve this problem called gas station. Now uh, what we have to do in this problem is we are given two arrays, two same length arrays. Okay, and one is the point. Basically, one is a point. One is a gas array and other is a cost array. Now what a specific index indicate is when we are at this particular index, then we can fill our tank with this much of gas, and this is a infinite volume, infinite capacity of tank. Okay, and the other thing is at the same index is the cost, how much cost is required to move to the next index. Okay, so first of all what we have to return is that particular index from where if we move rightwards and clockwise, rightwards and in circular motion, then we reach to the same index without being our tank being empty, such that we can move circularly and reach to the same index, and we need to find that particular index. So for example, if let's take the same example 1 2 3 4 5, and other is cost. If we start with index 0, then we can fill our tank with 0th gas, but we one amount of gas, but the cost to move to the next index is 3. Okay, and we have incomplete, basically inefficient capacity inside our tank, so we cannot move from 0 to 1, so we cannot move from 0th index. Now let's start with first index. So for this we can fill our tank with two amount of gas, but the cost to reach to the next index is 4. So which is basically our tank does not have enough capacity to such that we can move to the next index. So we will try with index 2, and the same will happen with index 2. Now when we will start with index 3, our tank will have 4 amount of gas, and the cost to move to the next index is 1. So so we can move to the next index. Okay, we can move to the next index, and the amount which when we will reach the next index, our tank will have 3 amount of volume. So when we will reach the 4th index, we can fill our tank with the complete volume, that means 5, and the amount to reach to the next index, that means 0th index, is 2. So it will take 2 amount of gas. So now when we will reach to the next index, we will have 8 minus 2, that means 6 amount of gas, and we can reach to the 0th index. So for 0th index, the amount of gas required, we can fill our tank with 1 amount of gas, and the cost to move to the next index is 3. So 6 minus 3 is 3 plus 1 4. So 4, with 4 amount of gas we can move to the first index, and for 4 we can have 4 plus 2 6 amount of gas, and the cost will be 4. So 4 plus 6 minus 4 will be 2. Okay, so with 2 amount of gas, we can move to the next index, that means 3. And with 3 with 0 1 second when we will reach the second index, we can fill our tank with 3 amount of gas, and the cost will be 5. So we can move to the next index. We can move to the next index, that means the third index from which we have started. We are just being able to reach to the starting position, so we have to return that particular index such that we can able to complete our cycle of the array. Imagine this being a circular array. Okay, so we have to return 3 in this case, as and it is given in the question that the answer should be unique. The test cases are generated such that the answer will always be unique. Okay, now how can we approach this question? So after thinking quite a while, we can first of all think of the brute force solution. Okay, which is like this. We can basically think we can basically think every index as the starting position. Okay, and we will check for each index whether we are able to complete this cycle or not. Okay, so basically for 0th index, if at this particular index we have our tank with negative amount of capacity, okay, that means we cannot able to move further, because it is not possible for us to move to the next position. Okay, so at each index we have to test it. So in worst case it will have O of n square of time complexity, right? Because for 0th index we will try, and then for first index we will try again, for how much at how much range our car or our tank can move, right? At each index we need to find at how much range we can able to move, or we can complete the cycle or not. If we are able to complete a cycle at one particular index, then that would be our answer. So you can basically by intuition or by just observation, you can check that this particular solution will have O of n square of time complexity. Now can we do better? Okay, so when I was given this question, I was thinking about this question. I have generated my solution using only brute force. Using only brute force, I was able to solve this question. Now how was that? So first of all, what I was thinking is, let us say at this particular index we have started at index I, for example, right? And there are many positions in between, correct? So we have started with index I, and what we are able to get is when we reach to the index J, our tank capacity had become negative, less than 0. Okay, at this particular jth index our tank capacity have become 0. Let's think about this case. Okay, so we don't need to consider every position in between. Now how can I say this? Because if I reach middle index this, then either I have come here with 0th or some positive value. So our previous range will only help this index to grow, our tank to grow only. So for example, when we have reached this particular index, its previous range where we have started and all the in between ranges has helped this question, has helped this index to grow only. Whether these are have some, our tank will have some positive value or zero only. With negative value we cannot reach to this particular index. Am I clear? Am I clear? But if its previous indexes cannot able to help this particular index to grow, then why are we even care about all the starting positions in between? Am I clear? These are of no use to us. We need not to check every position between I to j. We need not we should not able to, or there is no necessity to check each index between I to j as a starting position, because if this does not help, then the in between indices will also not able to help this to grow. Okay, so we can directly move our starting position to j plus 1 directly. We will just move our I to j plus 1 and we will check from here. So this was my intuition, and through this only I have generated my solution. So how basically how this will work. So for example, I had some test cases. Let's take some test case which is failed for my case. Okay, so let's take this. Okay, 452653. These are our gases at each index, and these are our cost 327329. Okay, so let's say we have started with index I, correct? So let's say we have started with index I and we have filled our tank. This is our tank, and we have filled our tank. This is our starting position. Okay, I am considering I as my starting position. So I can fill my tank with 4 amount of gas, and I can move to I plus 1 with 3 amount of gas. Okay, with 3 cost I can move to I plus 1. So when I will reach I plus 1, I will have so basically there is one pointer which is with the help of which I will this jth pointer will help me by how much I can grow this range. So my jth will be at I first of all, so it is positive, so I will move my j to first index, and I will check now I will with I have reached I plus 1 with 1 amount of gas. Okay, and I can fill my gas with 5 amount, so I will have total 6 amount, and with cost 2 I can move to I plus 2. So 5 plus 1 is 6 minus 2, 4, and I can move to index 2. My j can move to index 2. Now I will again check, and I can see that 4 plus 2 is 6. I will have now 6 amount of gas, but for moving to index j plus 1 I should have greater than 6 or equal to 6 amount of I should have at least 7 amount of gas. So as I can see, my total was less than 0, less than or equal less than 0, so I cannot move here. I cannot move to this position with index starting with 0. Okay, so as I was saying before, I cannot move to this position while starting with 0, but if I equal to 0 didn't help me to reach to index 0 1 2 3. If 0th index does not help me to reaching 0 to index 3, then 1 and 2 index will also be inappropriate for this case, as my previous index has always helped me to grow. So for this particular case 1 is added, for this particular case 4 is added. If I have started in between, then my tank will always be more lesser than before. Okay, so as I cannot move to this position, so I will move my starting position to index 3. I will change my starting position to here, and I will refill my tank with index 6 with gas 6, and it will cost me 3 amount of gas. So my J will now, as I have moved I should also have to move J. Okay, so as this is positive, I can move to next position with index 3. I will have gas 5 and cost 2. So as this is also positive, I can move to next position with index 6. 3 plus 5 8 minus 2 is 6. So I can move to next position. Now I can fill my tank with index 3 9, and it will take me 4 amount of cost to reach to next index. That means as there is no next index, so I have to move my jth pointer to 0. So 6 plus 3 minus 4 is 9 minus 4 is 5. So I have moved this at this 0th position with tank with gas 5, and I can increase my gas 4 and cost 3. It will take 3 amount of cost. So 5 plus 4 9 minus 3 is 6. I can move to next position with gas 6. So I am just fast forwarding it now. 6 plus 5 is 11 minus 2, and now 11 minus 2 is 9. Okay, 11 minus 2 is 9. Now 9 plus 2 is 11. 9 plus 2 minus 7. 9 plus 2 is 11 minus 7 is 2. Okay, oh sorry, 11 minus 7 is 4. 6 and 5 11 minus 2 is 9. 9 plus 2 11 minus 7 is 4, and I can move here, but expected was minus 1. I think I have missed something. 4 5 2 6 5 3 3 2 7 3 2 9. This was 9. Oh sorry, this was 9, and I think I have considered it as 4, right? Sorry. So 6 plus 3 9 minus 9 will be 0. So I will move here with 0th index. 0 plus 4 minus 3 will be 1. 1 plus 5 6 minus 2 will be 4. Now 4 plus 2 will be 6. 6 minus 7 I cannot move, so I will change my jth pointer now to next. I will change my I and j to the next j. Okay, I have to move to the next j. Sorry. Let's revert it. So I will have to, as I can see, my j is now less than I, so such that it will not move to infinite loop, as I can see. So I because for this case I have to move my jth location again to here, again to the, I think, same position, right? So as I can see, when j will be less than or equal to I can just return minus 1. So there will be two cases when I can return minus 1, whether when I is less than or equal to I, less than I, sorry, if I have reached the same location, then that means I have already then that would be my answer. So there are two cases when my solution fail, when I have to return -1, that is when j is less than I, or when I have reached to the j reached to the length of the array, because I was starting with 0 1 2 3 4, and when I make my I move here, then I have to return -1. That means there will be no such cases possible, right? So let's take one more good case, and that so let's take one small and good case. So let's consider the same 1 2 3 4 5 3 4 5 1 2. I am fast forwarding again. So I have filled my tank with I have chosen is 0 first. So first of all, I 1 -3, that could not be my answer, so I have moved I to j plus 1. Okay, so now I will move here. This will also fail. 2 -4, this will also fail, so I will move again my I will again move my I to j plus 1. Now I am checking here. So I and j, I have to move both. So now 3 -5 is will again fail. This is negative. Okay, so I will again move I with I to j plus 1. Now I can fill my tank with index 4. It will take me one amount of gas. So I have reached to next index, and I can fill 3 plus 5 minus 2, 8 minus 2 is 6. This is positive, so I can move next to next. 6 plus 1 minus 3, 6 plus 1 is 7, minus 3 is 4. I can move now here. 4 plus 2 is 6. Minus 4 will be 2. 2 plus 3 will be 5. I have reached here. Okay, so 2 plus 3 will be 5, minus 5 will be 0, and with 0 at the tank I can move to the same position. When I can see that I is equals to j, I can return the same I. Okay, now that will be my answer. So hope I am clear, and I am able to help you with this question. Basically this approach can be known as sliding window, but not completely. This is not completely a sliding window, but slightly a sliding window technique. Sliding window technique, where I am not moving my ith pointer. Again, I am not basically increasing my ith point. I am not by 1, but I am moving my ith pointer to j plus 1. That is the slight change between this approach and sliding window, basically standard sliding window. So hope I am able to help you with this question, and as you can see, this is a O of n approach. Okay, because I am just checking every I, not every I, but basically I am just skipping in between ranges and moving my pointer to j I plus 1. That means j plus 1, sorry, not I plus 1, but I am moving my pointer to j plus 1. So yeah, that's the solution. Hope I am able to generate some value in you. Thanks.